we've talked about before how like maybe in the future, all of us are going to be like managers of these
Yes.
agents who are like responsible for their work, but kicking them off and like when then editing their work and so on is like kind of a paradigm that you start to see in some of the coding, like people are very good with AI coding.
I think that's absolutely where the space is headed, and like what the exact future looks like, I don't know. But like, yeah, I think like you start to become a manager of these agents. It's doing work, and there's some really interesting ideas there around UX as well. Like, is it like a video game almost, where you see your little agents running
Yeah.
around, or like what is the right interface for managing this fleet of agents?
Hi, I'm Ben Kus, CTO of Box, and today I'm joined by Harrison Chase, the founder and CEO of LangChain. And today we're going to be talking about AI and the evolution of AI agents into more autonomous agents. Harrison, welcome to the show. Tell us about yourself and about LangChain.
Thanks for having me. Excited to be here. My name is Harrison, co-founder CEO of LangChain. Backgrounds in like ML ops. So studied stats and computer science. Worked at a fintech company doing ML, and then at an ML ops startup, and started LangChain as an open source project about almost exactly 3 years ago. And so that was a month before ChatGPT. Was going to a bunch of meetups. A lot of folks were doing things with stable diffusion and audio and visual models. But there's a few crazy folks doing things with LLMs, and I saw some stuff there. And some of the things I'd done previously was in NLP, and thought that was like really cool and really novel, and loved the generality of these models, and started LangChain as a Python package that basically took some of the common patterns that people were doing and put that into a Python package and tweeted it out, and went from there. And then a few months later started a company around it, and that's LangChain, the company. And we've been at it for the past 2.5 years or something like that.
That's crazy. I didn't realize you started it right before ChatGPT came out.
You could not ask for better timing. Yeah.
During this time, you've been going through this evolution of AI models, and an evolution of your framework. So one question that we've talked about a bit on some of our episodes is, what is an agent? And it, sort of in the idea that like this is a very controversial topic for CTOs. It makes people get in fights and so on. But can you give us your definition of it and talk a little bit about how when you first started to think about agents versus just AI models?
Yeah, there are a lot of different definitions of it. I do think that for the more technical definitions have probably coalesced around the idea of an LLM running in a loop, calling tools until it decides that it's done. And I think like from a very technical point of view, that is probably what most people mean when they say agents. Now, there are other views, like people like maybe zooming out a little bit and then some more, like some people add in the ideas of like planning and memory, and like, yes, like I think the LLM is implicitly doing planning, and memory is probably relevant and needed for these agents, but I'd say that's a little bit more zoomed out. And then even more zoomed out, LLM powered system that does something for you or something like that, and starts to get the intent of what you use it for. And so I like the more technical definition, and so that's what I mean. And I think most developers probably mean that when they say agent. Now, what this has kind of looked like has evolved over time. And what I mean by that is there's a really good quote by Andrew Ng that I liked 2 years ago, and I think I still like it now. But I think now that there's this like more agreed upon notion of an agent, it's maybe a little less relevant. But it was basically like, let's stop trying to define what an agent is and talk about how agentic a system is.
Yeah.
And because I think this was like really early on, realistically, like running the LLM in a loop didn't work nearly as well as it did today. And so
it's like the auto GPT, baby AGI world back in the day.
Yeah, you'd have that inspiration, but it was, it didn't work amazingly. And so the things that people were putting in production kind of like started from there, and then like added in more determinism in certain parts, and started to branch out. And so these systems, to overcome basically the models, a combination of the models not being good enough, and also like us not understanding best practices of how to just like run in a loop, started kind of like becoming more workflowy-esque over time. And so there's just like initial spark where, the projects you mentioned, AutoGPT, Baby AGI, like had that like running in a loop. And actually, I think this is interesting to folks because, or this is a useful thing, because LLMs, they're useful because they're general.
Yeah.
The simple run in a loop, it's also very general.
Yeah.
Like it's so simple and it's so general, but like that captured. So then people went to workflows, and now I think as the models are getting better, it actually is possible to just like run in a loop and call tools.
So one of the things that I think that we noticed, and certainly seemingly a lot of people noticed, is back in the day, let's say the GPT 3.5 era, if you got an agent running in a loop, sometimes it was totally awesome, but sometimes it would kind of spiral out. It'd almost like accumulate errors as it got distracted. It almost like distracted itself. And so that was kind of one of the biggest problems in the early days. And so can you reflect on sort of why that didn't work before, but it works now?
I think a big part of it, honestly, is that the models were just not good enough and they're just better now. I think you said like sometimes it worked. It barely worked. Like it worked, one in,
Yeah.
N times, and you'd get
Yeah.
a Twitter demo around that.
Yeah.
And it would also work for shorter time horizons.
Yeah.
So it would work like maybe the first tool call. We had like the examples in the LangChain docs were like, what is the age of Leonardo DiCaprio's girlfriend raised to the XX power? And so that would be like 3 tool calls: a search, and then another search, and then like a calculator tool, and then that was it. And that's fine, but like when we think about what we were asking these agents to do, they'd in theory require a lot more tool calls than that. And so I think like I don't know if it was so much that like the errors would compound,
Yeah.
or as like the context window growed, that
Yeah.
it just like wouldn't pay attention to what was in there. But basically it didn't work amazingly well.
Yeah.
And I think a big part of it is the models have just gotten better.
Yeah. And so I think you've probably lived in this world of like this word agents, which did not used to be part of what everybody would talk about, but nowadays is what everybody talks about. And there's been this evolution of not only your framework, but an evolution of sort of the way that the industry talks about it. Can you walk us through sort of like you have an AI model?
Yep.
Today you have these new sophisticated agents. Along the way, there's been multiple steps to get there. Can you tell us like how you see these like eras or this way that AI agents have evolved even before they were called AI agents?
Yeah. I'll probably focus on things that were like actually good enough to put in production, because I think, as mentioned, there's this tool calling thing there was always inspiration of that and sparks of that. But like realistically, the first things to go into production were probably like a single LLM call.
Yeah.
Like it was just like single call to an LLM. I mean, chatbots are kind of like this, right? And so like I think the first wave we saw was like chatbots or assistants, and they were called co-pilots, but they really didn't do that much
Yeah.
for you.
So this would be the like AI assistant style. Some people call them agents because they have a like almost like a personality, but maybe not technically definition agents, but somewhere in there.
It was basically like, yeah, I mean, it was basically like 1 or 2 LLM calls most. And so like, and some of these were in chat form, and those would be like the assistant style things. The first iteration of RAG, I would say, is like this, like, it would do a retrieval and then it would generate an answer.
Yeah.
Even simpler ones would just be like going from natural language to like SQL or something like that. It's just single shot.
Yep.
Then we started seeing people want to build more complex systems around these models. And that's where we get really excited. Like, we think LLMs are great, but we think it's way more interesting to build systems around them that connect them to data and APIs. And so then, okay, they're good enough to do this like single shot. How do we make it more complex? This is where, around the time where like Andrew Ng's quote came in, where he's like, yeah, let's talk about how agentic something is.
Yeah.
And so like then there'd be these like workflows, and it wasn't just like sequential workflows. Like there was like branching and looping, and they could get more. And this is where, like how agentic something is. The more branches, the more loops there were, the more agentic it would be.
I mean, we've talked a little bit on the show about the idea that there is actually a difference between a traditional workflow and an agent workflow, even though they look the same and they're represented the same. Like, how would you consider this difference between like somebody like workflow's been around? Every tool has workflow systems. And so what is a workflow versus an agent that has seemingly workflow-like components?
I would love to hear your answer to this as well, because now I'm curious. I mean, I would say, because in a workflow or an agent that has workflow steps, they still heavily utilize LLMs. You're probably utilizing them to make decisions. And so there's probably more like branching and conditional logic and fuzzy inputs and fuzzy logic as well, because it's like natural language. I don't know if that's how you guys think about them or define them.
I think the definition that I gave is that so you can have agents inside of workflows by sort of combining these things. But the idea of an agent is that the agent determines when to go to the next step, versus in a workflow, it's very specific. It has to go to the next step. The workflow engine enforces it. And so that's the difference between sort of a traditional workflow and an agentic workflow.
And when we talk about these like tool looping agents that's just running a loop and call tools, under the hood, they're exactly what you describe. Actually, they're a workflow where the agent decides what step to take, because it's deciding, do I call a tool or do I finish? And so it is exactly that.
Yeah. Okay, so then we're in this era of agents that are you're specifying sort of the graph style. You have LangGraph and your framework that kind of like highlights that. What happened to that? I mean, it's still around, right? Like,
yeah. So maybe even backing up, and I can talk about some like how we've thought about our frameworks over time, because I actually think like only very recently has new stuff started to become possible. So like the time trajectory is actually interesting. So we launched LangChain in late 2022, let's call it. And that was a lot of like simple chains, and some of these agents, but like initial calls. And then we saw that people wanted to do more complex things. And so in early 2024, and we'd really been building it since like fall of 2023, we launched LangGraph. So still like in the grand scheme of things, still relatively recently, but in AI years, like eons ago.
Yeah.
And that was basically part of this push where things started to become more graph-like and more, and people want more control every step.
And by graph in this case, it's like a computer science graph, like a little workflow oriented, it's like little nodes and edges, right?
Yeah, exactly. We would basically take this idea of a workflow or of an agentic workflow that people had and represent it as a graph, and like not a DAG. So there was absolutely cycles, because that was a key part.
I know a lot of people make this mistake. They call them DAGs when they're just directed graphs, not directed acyclic graphs. Yeah,
exactly.
Yeah.
And so I always want to add that in. And then only like recently, like I would say 6 months ago or something like this, I think, did we start to see like these agents that under the hood were this tool calling loop, but had other stuff packaged in, start to become more popular. And so, or start to really work. So like Manus, I would say, is an example of this. Claude Code, that was spring of this year, I think. All the deep research stuff, like that's an earlier variant of that, but that was like almost a precursor to that. And that was also spring or early winter of this year. And over the summer, so at least for me, it was relatively recently, I kind of looked at all these things and saw that they actually had a lot of things in common. And this is like I would actually bet that some people would be like, these are agents. Like, what do you mean? The stuff before, that wasn't agents. Like, these are actual agents. But I think we saw like they were different in some ways. One, the models had just gotten better, as we talked about. But two, I think as an industry had started to figure out like what the right harness for these agents would look like. And so there were common things, and you know, we now have a new package called Deep Agents, which is what we would call an agent harness. By the way, all these things stack on top of each other. So like LangGraph powers LangChain, which powers Deep Agents. But yeah, these are like higher level agents. They're still this core tool calling loop, but now there's a built-in planning tool. There's access to file systems. We do some things around compaction and truncation of tool results. And so this is kind of like industry best practices for running this LLM in a loop, which sounds kind of simple, but there's actually a ton of both like details, but also extra like batteries included you want to add to make it work.
One of the things that we experienced was as you go through and you're like, I need my agent to think more. And we started, terminology was always a challenge. Thinking agents, autonomous agents, you call them deep agents, which I think is a great terminology just to reference this point that they're almost like to-do planning agents as opposed to like do these series of steps. But then, so you can make a little graph like LangGraph style to make them work, but then you spend a lot of time sort of like dealing with like where the state is managed and so on. So, so then you built deep agents, and that just came out recently, right?
Yeah. And I think the two like core ideas here is really pushing back to simplicity. So it's saying like all the complexity of what would go in a workflow. And by the way, I do still think there's use cases where you do just want a workflow.
And what are those use cases?
I think when you have like a predetermined set of steps that you know you always want to take. But I would say that like I think more often than not, people think they have this predetermined sets, and there's actually some ambiguity, and it's actually not this predetermined set of steps. But if you actually do have like a predetermined set of steps that you always want to do, then great, like build a workflow. But for a lot of the things, like some people might try to mock out like research as a workflow. Research, I don't think, is a workflow at all. Like it's a really complex task that like requires a lot of intuition and choosing what to do. And so I think that's why deep research is both so impactful, but it also is built on top of this type of thing.
Yeah. We did deep research on a previous episode, and I think we got to the point where there's like 15 different nodes on a deep research graph, which these days with the newer models, you can probably incorporate into more of just a longer to-do list of these kind of things.
Well, if you're building these deep agents things, I think you really want to lean into this idea of big model maximalism or something. Just like the models are going to be good enough, and then just push all of the complexity into the prompt.
Yeah.
And the models actually are pretty good right now, and they're not perfect, but they'll absolutely get better over time.
And this idea of the prompt is an interesting, like I think people, when you're thinking about prompts, you're thinking about, oh yeah, like I type in prompts to ChatGPT, to others. I'm always prompting things, but these prompts, they're like
big.
like 20, 30 pages some cases.
Yes.
So like tell us about these prompts and how they fit into this whole scheme of like deep agents.
Yeah. So, I mean, you're pushing all the complexity into the prompt. And I think you're absolutely right that like if I sit down to write a prompt, I'm writing like 5 to 10 lines max, right? Like I'm not a good prompter. Most people aren't good prompters, but you look at like Claude Code's prompt or Manus's prompt. And by the way, things like tool descriptions absolutely count as prompts as well. This is another thing. Like I write a tool description, it's like 10 words.
Yeah.
Like you look like the tool descriptions for Claude Code are like longer than my full prompts often. And so like there's a ton of like complexity that goes into these prompts and instructions. And that's because you're pushing all the complexity into here. And I think writing prompts is actually quite difficult for most people. And so we also think about how can we make writing these prompts easier for folks? Because if you're pushing all the complexity into them, like it's actually quite easy to build a deep agent on top of the deep agent package. You specify a prompt and you specify some tools. And so like tools are like functions or MCP or whatever, and then prompt is just a string. But writing prompts are hard. And so there is a lot of complexity here. And then the other thing I'd say, just because you mentioned kind of like state of LangGraph earlier, the deep agents and all like Manus and deep research and Claude Code, obviously, they all use file systems. And I think file systems are great. Like they contain state. They are really flexible. So like you can have files in different formats. And so like, oh, you want like you want to start writing data that like is structured. Great, write a JSON file with that. You basically give the LLM the choice of how to structure kind of like the state that it's working with, as opposed to saying like, hey, it always has to generate this, and I'm going to track this specific state along the way.
Yeah, we're very into this idea. Like, of course, Box is kind of like, could be considered a file system in the cloud. And so the idea that LMs or these AI agents, the deep agents, are more into just like directly accessing this and using it as a tool is very much up our alley. So we're very excited about how this is naturally how we think about things.
I think there's probably a lot of really cool integrations we can do there. Yeah.
Excellent. Can you tell us about like, so there's this new paradigm, these deep agents that are coming out. They work a little bit differently. But like you said, there's been a lot of failed attempts ongoing. So what makes these deep agents, is this just another paradigm, or what, like, where is it working and where is it working well?
Yeah, I think there's a few things that have like caused it to start working. One is the models have just gotten better. The second is we've started to figure out things around the harness of these models. So like they generally do want some aspect of some planning tools actually. And these differ, but like Manus does it differently than does it Claude Code. Which is different than how we do it in deep agents package. But the harness is one thing that's gotten better, and the models have also gotten better. They work in situations where I think the right framing for them is when you want it to do a bunch of work, because I think that's where you get a lot of the value of like the planning and going deep into things, is when it actually does sizable chunks of work. But yeah, like they're still kind of like a first draft of things. And so I'd actually argue that if you look at like I think the big use case, the two big examples of this are coding agents with Claude Code and then Codex and everything else after that, and then all the deep research things. Those basically create like first drafts of something. Like coding agents create a first draft of PR or something like that, and same with deep research. It creates a report, but it doesn't publish it to a blog. It like sends it to you, and you can mark it up and stuff like that. So I think like basically, I think use cases like that where it does a sizable chunk of work, but it creates a first draft and there's still a human in the loop at the end are good. And oftentimes these are more read heavy than not, or there's a sizable like read heavy portion up front, because I think a big benefit of these deep agents is they often use sub agents in some form. And sub agents can be very dangerous to coordinate a bunch of like writing activities. Like imagine like splitting up an essay. We actually did, we did some like deep research initial prototypes, and like we used to have one that would like write different segments of the essay, but you don't know what the other segments are before you write them. So they don't like flow well together. So writing is like dangerous, but research you can parallelize a ton. And so deep agents oftentimes use this. So I think like, yeah, oftentimes when there's places where like research is needed, that's great for these things.
Sometimes when we're talking on this kind of show, we for people who don't build agents every day, we talk about sort of the mental model of how to think about these things, and often using like a human aspect of it. I think we described in the past that like one way to think about this is that you have contractors who just show up and they're smart people. They know a lot. They went to school, and then you hand them a set of instructions, which is basically the prompt, and then you ask them to do work. And then in this case with deep agents, the idea is you can just give them much more complex things, and then there's also this element of time. And I think this is maybe really critical, maybe like something that people don't talk about a lot. I think it used to be that like people would not wait. And therefore, it didn't matter if you could do something. They would just get so annoyed in the agentic experience that they would not like they don't want to wait 10 seconds. They're like, give it to me now. I'm used to computers responding immediately. And so even though if you gave it a minute or 5 minutes, it could actually respond quickly, but like no one would wait and they would consider it broken. And so, but then I think with ChatGPT, with Gemini, with Anthropic, with the coding tools and other things, you start to realize if I give a little bit more time, it gives me better answers, which of course is like people. And so it seems like this is a part of the evolution of these agents, is to let what people are comfortable with when they talk to them and when they experience them is changing as well.
Yeah, I think so. Maybe two comments here. Like one, like I think one of the more underexplored places is in around like just like UX of how to
Yeah.
interact with these agents just in general. I
Yeah.
think there's so much undiscovered things there, and that's something we're very, very interested in. Yeah, if you have this thing that works, but like people are getting mad because it's too long, what can you change about the UX to make it more acceptable? Then the other thing I'd say, and this is stealing a bit from Swix on Twitter, who has some good thoughts about coding agents. There's almost like this uncanny valley of time in the middle, where like if I'm working with something synchronously,
Yeah.
I want it to be super fast. I
Yeah.
want it to be like a second, two
Searching for
seconds.
something quickly, give
Exactly.
me this answer to this question inside of this thing. Yeah.
You want to be in flow state,
Yeah.
and but then on the other end of the spectrum, like when I interact with a coworker, often when I'm busy, I'll maybe check in with them at the start of the day and then check in with them at the end of the day. And
Yeah.
there's this huge period of time, and like I can go do other things. But there's this uncanny valley where if something takes like 2 minutes, it's maybe not doing like enough work where it's like a real sizable chunk for me to like be happy working with it. But it's also like I can't stay in the flow state with that, and I don't know exactly like is that 30 seconds, is that 2 minutes? But there's kind of this, you either want things to be very, very fast and very, very synchronous, or you actually just want it to do as much work as possible and you care less about the time that it takes. And so I think this gets back to just like different UXs and
Yeah.
experimenting with that.
I think it's also interesting that like sometimes you have like the same question that you want an AI to help with, but sometimes you want it to quickly answer. Sometimes you want it to like go to spend time, which is I think the difference between a traditional LLM response, which you often want, but then sometimes you want it to do research.
Yep.
Like and it's almost like you're unsatisfied if it came back to you quickly because you're like you probably didn't do enough work because I have a very deep question for you and I know that the same as a person, if you gave them a really difficult question and they're just answer off the top of their head, then they would probably be like, no, I want you to do some more work on that.
And I think there's some interesting UX considerations. Like, do you let people choose if they want a fast result or a
Yeah.
deep result, or like should it detect that like automatically,
Yeah.
or like are those two different interfaces
Yeah.
completely? Like, I don't know the answer to that, but like I do agree that confusion
Yeah.
often
We spend a lot of
manifests.
time on this question. Also, I've seen other products constantly change. Like, you click, you go to thinking mode, you click to go to
Yep.
slow mode, you change it, and you stop it, and so on. So I guess this is something that everybody's evolving towards. Okay, so for people who are like interested in this concept of like deep agents and more thinking agents, but like not everybody talks about it this way. So like if they're looking at different products, like maybe like enterprise platforms, or maybe they're thinking about things that they build, like can you kind of just give the summary of like why would they care about sort of whether it was one approach versus the other, and then how to recognize sort of these different modes?
Maybe I'll start with how to recognize different modes. I mean, I think like I think latency is a big one. Like I think like anything that's generally fast probably isn't doing too much thinking under the hood. It's generally not
Yeah.
going as deep on things. And I don't think that's like necessarily bad. I think it's just good to recognize that that's more of kind of like an assistive thing almost. Like when I use a coding tool in synchronous mode, I'm in the flow. It's not replacing me, it's
Yeah.
augmenting me. It's
Yeah.
very much in there.
Yeah.
On the other hand, when I use something in a more asynchronous mode, if I kick it off via Slack or something like that, it is like replacing the work that like I would have someone else on the team do or that I would do. And so like I think like that's a helpful distinction because like yeah, people will probably call both agents and like sure, fine, but like there is that difference between like almost like synchronous in the flow of things
Yeah.
versus starting to replace things. There's way more of the former like co-pilots and synchronous things.
Yeah.
And I think there, like the thing I'd say is just like have the expectation that this isn't going to replace someone. This is going to augment kind of like the work that they're doing. Whereas the more long running things, it's not going to replace a whole function, but it will let people do more with less. And we see this across a bunch of different industries.
We've talked about before how like maybe in the future all of us are going to be like managers of these
Yes.
agents who are like responsible for their work, but kicking them off and like when then editing their work and so on is like kind of a paradigm that you start to see in some of the coding, like people are very good with AI coding.
I think that's absolutely where the space is headed, and like what the exact future looks like, I don't know. But like, yeah, I think like you start to become a manager of these agents. It's doing work, and there's some really interesting ideas there around UX as well. Like, is it like a video game almost where you see your little agents running
Yeah.
around, or like what is the right interface for managing this fleet of agents?
Yeah.
That's probably like the first thing I just get a sense of is like, hey, if this product is saying it's got AI or it's an agent, like which of those styles is it?
Okay. And then the more time you give it, the more that you expect from it in a lot of ways.
Yeah, generally, yeah, and I'm sure there will constantly be a tension there where like models will get faster, so then you can kick these things off in the background and they'll go faster, but then you'll probably also ask them to do more, so then they'll take longer, and so yeah.
So there's an interesting dynamic for, especially for some of our enterprise audience, because one of the things that everybody's always thinking about is accuracy. And
Yeah.
they're thinking about like, is this going to work for me? Is this like, what's the percentage of the time it's right or wrong kind of thing? But then in this new style of agents, like it's very different because like what is a right answer, a wrong answer
Yeah.
can be like almost, not only is there not a giant eval set of like doing research, but like it's also something where like every activity is a little bit bespoke, right? It's almost
Yep.
like, how in this world do you think about eval sets? Do you think about accuracy? Do you think about how to like figure out if it's going to do something that is like actually going to work for you across all of these kind of agentic use cases?
Yeah. So and so maybe even starting with like the simpler stuff, just to set a baseline, like there typically what we see is people build up eval sets, inputs, outputs, run the agent or LLM against the inputs, get some new outputs, compare it to the expected one, use some metrics of some form, whether it's another LLM or some deterministic thing to score it, get some score and like make sure that that's trending up over time. You can still do some aspects of that with agents. It works well generally for when you're testing specific things. So like for example, I have an email agent that I built. Whenever email comes in and it's asking me if I'm free for a meeting, it should check the calendar. It should call the calendar tool. And so I can set up a pretty simple eval data set of like a few questions that I would expect to trigger that tool, and then just check that like tool was triggered within like the first one or two things. And like that's generally like pretty doable, pretty easy, but it starts to get more complex when you start to deal with longer chunks of
Yeah.
tool calls. So keeping kind of like the email assistant example, if I had to check multiple different calendars and maybe do some internet research to
Yeah.
like figure out like, hey, Harrison only likes meeting with companies that are based out of SF. It has to go off, do the research. You start to get this tool call that's like 30 tool calls long or something like
Yeah.
that. It's hard to come up with an expected like trajectory for that.
It's almost like evaluating somebody's work that's complex. You just kind of got to sit down and like look at it. And it's like hard to like give it yes or no, like test style answers.
Exactly. And so like human review and human looking at things absolutely starts to come in. You can maybe try to do stuff more just based on the output and is this black box, but oftentimes like agents will do multiple things. So like what is the output? It's not like it has a single answer. It has all the actions and all the side effects that it's taken along the way. And so another thing we've seen here is like you can test the side effects that it does. Like does it add a row to the database? And then basically you're testing the final output and all the side effects. And then the last thing I'd say is that I actually think there's a really interesting tie-in between evals and memory, actually, because I think a lot of the evals are best done by human experts, and I think the human experts are oftentimes the users. And so if I have an email assistant that I'm chatting with and it does something poorly, maybe the best, like a very good way to get feedback is via me saying, no, you did X, you should have done Y. And now, wouldn't it be great if it remembered that so it wouldn't make that mistake again in the future? Yes, it would be great. Wouldn't it also be great if it started to actually build its own eval set on some of these more like single tool calls things? And that's, we've started to do some stuff around memory. We haven't started to do stuff around it building its own eval set. I do think that like when you start to get to these long running complex things, like, yeah, the user is oftentimes the best evaluator. They have the domain
Yeah.
knowledge. And so if you can capture not just their sentiment, because thumbs up, thumbs down has been around for a while, but if you can start to capture like real, like, oh, it did X, it should have done Y, and like tie that in, that's one of the future things that we're really excited about.
That's interesting. I think one of the sort of the themes that you're highlighting is that we're not only like have gone through a state of tremendous change, AI models, agent frameworks, the way people are using these agents, the use cases they apply, and the paradigms by which you use them, but it's also continuing to change. And that's like hard for a lot of people who are trying to say like, I think I should start to use it now, or I should start to adopt it. Like, so how do you look at this idea that like seemingly things are they're not stopping. They continue to change. Like, what should people do to sort of not only keep up, but just like when should they start to like go down the path of trying and using these things?
I mean, I'm probably biased, but I think people should be trying them out all the time. And right now, there's no better time than now. I do think like we talk with a bunch of companies who are basically like, yeah, we are currently building this AI project. In a year, we may buy it from someone, but we're learning so much along the way. And I do agree with that sentiment. Like we talk about like the change from like chat to graph to some of these deep agents. There's absolutely things that we learned along the way that are still relevant in deep agents, like prompting techniques and how to think about that. The fact that like tool descriptions matter a lot, still matter a lot. Retrieval hasn't gone away. It's now just a tool that's used as part of these deep agents. These skills keep on kind of like compounding, and things build on top of each. Like we quite literally have LangGraph, and then LangChain builds on top of that, and then deep agents build on top of that. If we do this again in a year or 2 years, things will absolutely look different. But I think a lot of the same notions we have today will be around, and they might be at a lower level of the stack that's maybe not as readily available. But I think understanding that is good. And then yeah, there absolutely will be some things that are done today that won't be in the future. That's what we think about a lot as well. So like I think one of the initial use cases of LangChain was like chaining two LLMs together, two LLM calls together, like no data in the middle, no API in the middle, no nothing. And I think, yeah, we we didn't invest super heavily in that because we kind of thought like as the models get better, they'll just be able to do like, depending on what, for most of those things, that will just be one LLM call. And so I do think there's absolutely parts that are maybe just like in the here and now. If you guess wrong which parts are and aren't, it's not the end of the world.
Well, Harrison, thank you for coming here and for all your great insights, and looking forward to chatting again in a year.
Thank you for having me.